Hello, in this video we'll be looking at writing equations when we have a quadratic pattern. In the previous video we looked at linear patterns and those were pretty straightforward. But in the quadratic patterns you'll notice when you do your delta y's that they are not the same. Their second difference is the same but their first difference is not. So when the first difference is not the same but the second difference is, then I know that the equation has to be a quadratic. The easiest way to write a quadratic equation given a pattern is to take your first three y values that are greater than 0. So -3 is not greater than 0, 0 is not greater than 0, but 5, 12, and 21 are. So I'm going to list 5, 12, and 21. And to go ahead and factor each of those. So 1 times 5 gives me 5, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 1 times 21 is 21, 3 times 7. Notice you could also write 3 times 7 as 7 and 3. And what we're looking for from these is a pattern in your first column and then a linear pattern in your second column. So 1, 2, and 3. That forms a nice little pattern. Let's see if their numbers that are next to them form a pattern. 5, 6, and 7 also form a pattern. Once I find my two patterns, I make two t-charts to find what linear equation makes these. So the first thing you have to do is figure out what your x column is going to be. The x's that you want to use are the ones that you use for the y. So I use 5, 12, and 21, so my x's are 2, 3, and 4. Our goal here is to write two linear equations because if you remember, it's the product of two linear equations that actually make a quadratic. So 2, 3, 4 are my x's. My first set is 1, 2, 3. My second set is 5, 6, 7. Now we're going to write the equation that goes with this. Let's see, my slope is 1, so n, and then 1 times 2 is 2. How do I get to 1? I subtract 1, n minus 1. My slope here is 1, and 2 times 1 is 2. How do I get to 5? Well, I add 3. So I have n minus 1 times n plus 3. And we're going to go ahead and FOIL that, multiply everything. So n times n, and then n times 3n, so n squared plus 3n. Negative 1 times n is minus n. Negative 1 times 3 is minus 3. So it gives me n squared plus 2n minus 3. And that is going to be my n equation. If you plug in 20, you're going to get 20 squared plus 2 times 20 minus 3, which gives you 400 plus 40 plus minus 3 is going to be 437. Okay, on this next problem, try it on your own. Try to write out your factors of the numbers you're going to use for y. After you do that, write your linear equations that go with them, and then multiply them together. So pause the video at this point and try that. All right, let's give it a try. My difference from 35 to 72, well, that's going to be a big number, 37. Well, this is just to make sure it's not linear. So 72 to 121, 49, so you can already see that this is not going to be linear. So let's go ahead and take those numbers and factor them down. 35, 72, 121. Now, I know that 35 will only have a couple factors, and 121 will only have a couple factors. 72 is going to have a lot, so I'm going to start with my n ones that are a little easier. So 1 times 35 and 5 times 7. I'm going to come back to 72 because that's a big one. 1 times 121, 11 times 11. Let's see if I see a pattern at all. 5 to 11, okay, 7 to 11. So if I was going to find a pattern in the middle from 5 to 11, it would have to be 8. And then from 7 to 11, the middle would have to be 9. And is 8 times 9 72? Well, it is. So I can actually see that 5, 8, and 11 is one pattern. 7, 9, and 11 is another pattern. I could have also listed all the factors of 72 to look for that pattern. So now we're going to go ahead and draw our tables to find our linear equations. 35, 72, and 21, my x's corresponding were 2, 3, and 4. So 2, 3, and 4. These will be different depending on where you start with the y's. 5, 8, 11, 7, 9, 11. So this equation, let's see, my slope is up 3 each time. 3 times 2 is 6, minus 1 gives me 5. And my slope here is 2. 2 times 2 is 4, so 2n. And to get from 4 to 7, you add 3. So I'm going to do 3n minus 1 times 2n plus 3. So 3n, and then 3 there, so 6n squared plus 9n minus 2n minus 3 gives me 6n squared plus 7n minus 3. So that's what's going to go in the n blank. Plug in 20, you're going to get 6 times 20 squared plus 7 times 20 minus 3. So this is 400 times 6 is 2400 plus 140 minus 3 gives you 2537. Okay, this is a different set, and we'll look at why it's going to be a little different here. So let's pick our first 3 y's that are bigger than 0. 2, 5, and 9. Factor those, so you get 1 and 2, 1 and 5, 1 and 9, 3 and 3. And really, I should have checked to make sure it wasn't linear. So if I had done that, you would have seen 2, 3, 4. So not the same differences. Is there a pattern? 1 to, 1 to nothing over here. So no pattern. 2, 5, 8? Nope, no 8. Let's see. 1, 5, 9? Nope. There is no pattern whatsoever on this problem. So what am I to do? Well, when you don't find a pattern, you take those 3 numbers you were going to use and you double them. So double 2 is 4, double 5 is 10, double 9 is 18. Factor those down. 1 times 4, 2 times 2. 1 times 10, 2 times 5. 1 times 18, 2 times 9, 3 times 6. And look for a pattern. Well, let's see. 1, 2, 3, 4, 5, 6. So you have to remember, though, that you multiplied by 2 at the beginning. So now we're going to go ahead and make our tables like we did before, and realize that once again we start with 2, 3, and 4 on x. So 1, 2, 3 is my first pattern. 4, 5, 6 is my second pattern. So this is going to be n minus 1, and this is going to be n plus 2. And so we're going to take those. And the only new step here now is because I multiplied by 2 at the beginning, I now need to go ahead and divide by 2. So multiply out, you get n squared plus 2n minus 2 over 2, which reduces down to n squared plus n minus 2 over 2. And that is your final answer for the equation. Plug in 20. 20 squared is 400, plus 20 is 420, minus 2 is 418. Go ahead and divide that by 2, and you're going to get 209. All right, let's move on for one more problem. Pause the video and try to write the equation for this pattern. Okay, welcome back. Hopefully you checked it and saw that you have 4, 7, 10, and 13, so your difference is not linear. So let's go ahead and write 4, 11, and 21. Factor 4, 1 times 4, 2 times 2. 11 is just 1 times 11. And 21 is 1 times 21, 3 times 7. So let's see, 1, nope, no pattern there. 1, 11, 21. Okay, that went by 10. That might work. If I reversed it, if I had 11 and 1, and 21 and 1, so 1, 11, 21, that went by 10. But 4, 1, 1, nope, that's not a pattern. Let's see, 2, 11, I would need 20 over here. No, no 20. Okay, so I got no pattern with 4, 11, and 21. So let's go ahead and take each of those and double them. 8, 22, 42. Let's factor that now. 1 times 8, 2 times 4. 1 times 22, 2 times 11. 1 times 42, 2 times 21. Let's see, 3 times 14, and 6 times 7. Let's see if we see a pattern. 1, 2, 3. Well, that looks promising. 8, 11, 14. Hey, that goes by 3, so there is a pattern. 1, 2, 3, 8, 11, 14. So I'm going to go ahead and make my two tables now. And once again, I started with 2, 3, 4, and X, but just realize that that's not always going to be the case. So 1, 2, 3, 8, 11, 14. So my slope is 1, and to go from 2 to 1, I subtract 1. My slope here is 3, so 3n. 3 times 2 is 6, plus 2 is 8. So I'm going to take those two, n minus 1 times 3n plus 2, and I'm going to divide that by 2, because remember at the beginning I multiplied by 2 to get the 8, 22, and 42. So you get 3n squared plus 2n minus 3n minus 2 all over 2. 3n squared minus n minus 2 over 2 is your final equation. You plug in 20, 3 times 20 squared, minus 20 minus 2 divided by 2. 20 squared is 400, so 1200 minus 20 minus 2 over 2. Let's see, it's 1180. 1178 divided by 2 is going to give you 500 and, let's see, 89. Thank you for watching. I hope you got something out of that.